Welcome back, everybody. Here's number 11. So we're going to jump right back into the exam review. Right here today, 2, 4, 6, 8, 10, 12. Yes. What a day. What a day. What a day. What a day. All here. I mean, you guys are seniors in high school. You got your whole life, man. What you guys are just like. If I could go back to my senior year, no, I wouldn't do it. I wouldn't do it.
No, I wouldn't. I would never go back to this chapter of my life ever.
You know, it's funny. It's like all those people that were like, "Oh, high school was the best time of my life." Like, wow, really? Like 18 years old, that was your peak?
That was your.
That was it?
That's a bit sad.
That's sad, you know. I mean, I'm having a good time now. My kids are like perfect at 5 and 2. Emmy slept without her passing for the first time 2 nights ago. She is so proud of herself. So proud of herself.
She should be. And we had a pacifier fairy when I was little.
Well, we had to with Sadie. She was still sleeping with it when she was like 4 and a half. It was literally like right before quarantine happened that we had to like take it from her. But the Passy Princess had to come and leave her a little present. You know, it was funny. We got a friend that she actually like tied it to the end of a balloon to let it float up, right? And so she tied it to the end of the balloon, and the kid like let it go. It got caught on the power line right next to and it was like hovering outside of her bedroom window the night she was trying to fall asleep. And apparently she was like banging on the window. I know. I'm sorry. Okay, here we go. Yeah, all we do here is just plug in 4. Right? Sorry, back. All we got to do is plug in 4. We can calculate the rate of the balloon as it goes up to the sky. Instantaneous speed of the balloon. So all we need to do is plug in 4. How do we know we can plug in 4?
Because it
doesn't make the bottom 0, right?
Yeah.
I can actually it is defined at 4, right? The limit as x equals 4 is f of 4. So all we need to do is just say, excuse me, square root of 4 plus 12 minus 5 over 2 times 4 minus 1. All right, so that's square root of 16, which is 4. And then 8 minus 1 is 7, so negative 1/7. Is that what you guys got?
Yep.
Perfect. Easy problem. Yeah. This is where we really begun with chapter 2. Like this. Well, I guess that's not true. The continuity stuff, that was chapter 2 as well. All right, so let's get to 12. Evaluate the following limit. Now, can I plug in 3? No, I cannot do direct substitution because the limit does not exist. Excuse me. The limit exists, just f of 3 is undefined. So I have to do something to kind of rearrange it, simplify it down, something else. And I see that this is factorable. Factors of negative 15 that I had to get to 2 are positive 5 and negative 3. X squared minus 9 is a minus 3 plus 3, which, fancy, cancels. So this is an x plus 5 over x plus 3. So I can calculate the limit as x goes to 3 of x plus 5 over x plus 3, which now we can plug in because we've reduced it down. Plug it in, that's 3 plus 5 is 8 over 6, which is 4/3. Excuse me. Questions about that one? What's that?
Whole exam.
Whole exams? That was back in chapter 2 test, you guys were like, this is so hard. Given the following function, find the limit as 4 from the left, the limit 4 from the right, and the limit 4 total. Okay, so let's find the limit as x approaches 4 from the left. Okay, what is directly underneath 4? 10 minus x, right? Any number that's leading up to 4 from the low end, from the left side, like 3.9. If I plug in 3.9, I got to go into 10 minus x, right? So the limit as x approaches 4 from the left side is 10 minus 4. So 6. So this is equivalent to 6. Let's check the limit as x approaches 4 from the right. All right, so this is x minus 5 squared. So 4 minus 5 squared, well, that's negative 1 squared, which is 1. So the limit as x approaches 4 from the right is 1. What is the full limit then? Does not exist. Right. The full limit does not exist because left side limit must match right side limit for the limit to exist. And we also can say that there is a discontinuity there, right? I don't know what kind. It's probably a jump, but is actually it's not defined there, right? There's no or equal to. So it definitely is a jump. There is no f of 4 does not exist. So therefore there is a discontinuity there, a jump discontinuity. Okay. Let's keep it going. Here's 14. Oh, using the epsilon delta definition of a limit, find the delta that would be required to prove this limit. Ooh. I gotta get my key out real quick. Oh, please. I gotta make sure. I don't want to steer you in the wrong direction. I'll cue this. Cue this. Did I not update the calendar? What? I didn't update my Google slide. Jeez. I mean, we're just doing exam review, so it doesn't really matter.
Delta epsilon.
I know, this was that weird thing. Remember that?
I never liked
Delta
that.
epsilon definition of a limit. Okay. I do what I was doing there. All right. All right, so the limit as x approaches 10 of 3x plus 5 is 35. Now, did we even need to know that it actually was 35? No, we could have solved that, right? If I wanted to find the limit as x approaches 10 of 3x plus 5, just plug it in. 3 times 10 is 30 plus 5 is 35. But I want to know, how close do I need to be? What is the delta to make the epsilon match up? All right, what does that mean? That means that I want to know, we can say that we want to find this, right? The absolute value of x minus 10 has to be less than delta. Fancy looking D for delta, right? Okay, so 3x plus 5, the actual value of the function, take away the actual value of the limit, right? F of x minus 35 has to be less than epsilon. Oh, I don't need absolute value there. Sorry. Has to be less than epsilon. Because that's the true epsilon delta definition, right? I want to figure out how close my x's need to be to ensure my limit actually comes out near 35. Because that's the idea of a limit, getting closer and closer to 10 without actually ever reaching 10. How close does it need that we can assume it to be 10? Well, let's reduce this down. 3x minus 30. Pull out the 3. So x minus 10 is less than epsilon over 3. So find the delta that would be required to prove this limit. So delta is, so look at this statement and this statement. If x minus 10 is less than delta and x minus 10 is less than epsilon over 3, then delta is equivalent to epsilon over 3. So whatever I choose to be close enough for my epsilon, say I only wanted to be 0.1 away, then the x values that I would choose would have to be 0.1 divided by 3 away.
And you got the x minus 10 because it was like when the matrices.
Because I'm saying the difference of x away from 10 is my delta, right? How close do I need to get to 10? The difference away from 10. As I approach x, how close do I need to get to 10 to ensure it to be close enough to 35? How close? Epsilon close. We didn't decide that in this one. We're just making it arbitrary.
Yeah, okay.
Does that make sense?
Yep, I got it.
Sorry, I went on a really long spiel for just to say like, yeah, I got it from there. Curvy D. Curvy D and a backwards 3. Okay. All right. Use the graph of f of x to calculate the limits. We got this one. This is 15. Okay, the limit as x approaches -4. And notice the notation there. I'm not saying 4 from the left. I'm saying as it approaches -4. Okay, where is it as it approaches -4? What's the value of the function at -4? -3. Don't overthink that one. If the function is running through that point, then that just means f of -4 is the value of the limit as well. So it ends up just being -3. Let's keep going down the left side. F limit as x approaches 5. Okay, so where is 5? 5 comma. Let's make it right there. -4. Looks like it might be a little below -4, but we're just a little rounding. Limit as x approaches 7. 6. The limit as x approaches -2. Now, I say -2 from the left. Right?
Yeah.
What is the limit as x approaches -2 from the left? -3. Let's jump to 2 on the right. Let's jump to this blank over here. 2 on the right. What is the limit as x approaches -2 on the right? +1. What is the full limit? It doesn't exist. Okay, what about 8 from the left? What about 8 from the left? Looks like 7. What about 8 from the right? Doesn't exist, right? I know I didn't ask that, but we said it was 7 up there. Yeah. 8 from the right doesn't exist. So does the full limit exist? No. It has to exist at both parts. And then the limit as x approaches 6. What would be the limit as x approaches 6? Mr. Buckerfield. Now, can you answer this question, Mr. Buckerfield? Mr. Buckerfield came in and answered a solving equations question. But can you solve this question? Mr. Buckerfield, what is the limit of f of x as x approaches 6?
-6?
Wait,
Wait, what?
What is the limit as x approaches 6 of f of x?
Doesn't exist.
Very good, Mr. Buckerfield. That's recorded right there. That you got that question
Does not exist.
correct. Very good, Mr. Buckerfield.
Have a good day.
You too. All right, questions about that one? You were like -6. He just went for it. All right. Any questions on that one? Okay. Ooh, this one looks fun. What was your definition? Oh no. My definition of fun. Okay. Can I plug in 0?
No.
Bummer. So let's reduce down the top and then divide it by x and see if we can do anything to it. So this is the numerator. 1 over x plus 4 minus 1/4. All right, so let's get common denominators. Let's multiply the left side by 4 over 4 and multiply the right side by x plus 4 over x plus 4. Which will get us 4 over 4 quantity x plus 4 minus x plus 4 over 4 quantity x plus 4. All right, so my common denominators stay. So that's equivalent to 4 minus, now be careful here, I got to distribute that negative. 4 minus x minus 4 over 4 quantity x plus 4. Okay, canceling out my 4s, I get a negative x over 4 quantity x plus 4. Now that is on my numerator, right? So that's like saying that that's equivalent to negative x over 4 quantity x plus 4 all over x. Now, I'm going to turn this division into a multiplication. Because now, if I do that, I can multiply by the reciprocal, which is 1 over x, and cancel out that x. Which will leave us with negative 1 over 4 quantity x plus 4. Now, can I plug in 0? Yeah. So this would be negative 1 over 4 quantity. 0 plus 4 is 4. So negative 1/16 is my limit. Questions about that one? Let's just see if people copy. Now leave it there for a second. Questions about that one? We good? Okay, let's get to the next one. All right, we got some infinite limits now. Still in chapter 2. Got some infinite limits. So, negative 3 from the left. Now, check out what's happening at negative 3. There's an asymptote. Okay, negative 3 from the left. What's happening? Where's it going to?
Infinity.
Positive infinity, right? Up. You don't need the plus sign, but... Okay, negative 3 from the right now. Positive infinity again. Negative 3 total. Positive infinity. Okay, let's take a look. Okay, I'm looking at 2. 2 from the left. Negative infinity. 2 from the right. Positive infinity. 2 total. Does not exist. Good. Seems solid with that one. That one was a good one.
Yeah. No. And there's always a no.
The next one is a no. Another one of these guys.
I remember this question on test.
Yeah.
I just want to say not.
This is a good one. Again, what are we finding the limit as x approaches? The limit as x approaches what? 4, right? What are they giving us as our epsilon? Do I even need to? It tells you that within the problem. But look at the graph. Just look at the graph, and are you able to tell what the epsilon is? The epsilon is 0.4, and you can see that right here, because it's saying, okay, I want my outputs to get within 0.4 of the actual value. If I want my outputs to get within 0.4 of my actual value, what do I need my inputs to be? How close to the actual value of 4 do I need to get to make my actual value to be of the output to become 0.4? Well, I need to figure out basically this coordinate and this coordinate. Figure out what those x values are. Okay, well, let's figure out those x values. I say the y value is 1.6 is equal to the square root of x. Right? That gives us this coordinate. Square 1.6 2.56. Let's do the same thing for the upper boundary. So 2.4 is equal to radical x squared 2.4, 5.76. Okay, so this is 2.56. This is 5.76. So let me ask you, to ensure that I will get within that window for my y values, which x value am I going to pick? Because it's closer, right? We're going to pick 2.56. See the difference away here, 4 minus 2.56, 4 minus 2.56 is 1.44. The difference away here, 5.76 minus 4, is 1.76. So I'm going to choose the closer value. So what is my delta? 1.44 is my delta. Okay. Oh, that's a funky looking delta. 1.44. Okay. That gets me closer on either. It actually gets me closer than I need to on the right side. Like 1.44 above 4 is 5.44, right? That's my upper boundary because it needs to be the same on upper and lower boundary for my x. That wasn't too bad.
I remember that being more.
I know. See, that's the thing. We always look back and, hindsight is 20/20, right, Mr. Bucksfield?
Yeah.
Hindsight
I
is
also
20/20.
just think that on the
DNA,
quiz-
DNA.
DNA.
On the quiz, it was a little bit. The number.
Keep on this thing. Oh, this is fun, so much fun. Have a good one.
You're gonna do this again, aren't you?
Yeah, oh, absolutely.
I don't know why you just.
Yeah.
did that.
Yeah.
Absolutely.
All right. Find all holes, horizontal asymptotes, and vertical asymptotes. Did we already do a question like this?
Yeah.
Yes.
All right, we did this twice.
Why not extra practice?
Extra practice, I guess. Extra practice.
I need it.
And also so it wasn't very many questions.
What's that?
Also so it wasn't very many
And these ones, the exponents are the same, which means that you have to look at the coefficient, but they're also the same, which means I have no idea.
Which
I got
therefore
that
means
far.
I got it. You are right. And you were right. You have to look at the leading coefficient. We'll get there in a second. Let's find holes first, because that's what it asks us to find. Now, to find holes and asymptotes, I need to factor this all down, right?
Yeah.
Okay, so the top becomes x minus 6, no, plus 6, x minus 2, right? X plus 6, x minus 2. The bottom becomes x plus 6, x minus 5. So this function simplifies down into x minus 2 over x minus 5, right? Where's the hole? Where's the hole? Not at 5. That's a vertical asymptote. At
Oh,
-6. Remember, this is the hole, right? That is the hole. So there's a hole at x equals -6. If you want to find the exact coordinate, just plug it into the reduced down function. Okay, -8 over -11, -8 11ths, -6 comma 8 11ths. But I'm okay with you just give me the x value. Okay, holes, check. Let's find horizontal asymptotes. Now this is the thing that Camille was talking about. Remember the top heavy, bottom heavy are equal thing. Remember that if it's top heavy, it doesn't have horizontal asymptotes. If it's bottom heavy, it has a horizontal asymptote at 0. If it's equivalent, you look at the leading coefficients. So she got to the point where she said, okay, I know that they're the same, but what does that mean? That means you just have 1. You just divide the leading coefficients. So since it's 1 over 1, the horizontal asymptote is at y equals 1. Now, where's the vertical asymptote then? At x equals 5. Is there a vertical asymptote at -6? No. There was a hole at -6. Okay? There was a hole at -6. Honestly, what are you looking at here then? You're looking at anywhere where there was a discontinuity, right? There was a discontinuity at -6 and 5. The discontinuity is a jump discontinuity or a removable discontinuity at -6, where it was an infinite discontinuity at 5 because it went to a vertical asymptote.
So for holes, it's just if the top and bottom have the same equation in them. So like
Right, whatever cancels out from top to bottom.
So in the one that we already did, we found the domain. So if we found the domain of this one, to use to 6.
Yeah, all numbers but -6 and +5. Yeah. The domain would be any number except for -6 or +5. Because even though there's a hole there, it's still not part of our domain. It jumps that point. Questions about that one? It's your weird graph. All right, let's keep going. Moving right along. Find the following limit. How do I find an infinite limit like this in a rational function? Anybody remember the technique?
Divide by the biggest one.
The biggest one.
Yeah.
Divide by the biggest power on x. Divide by the one, the thing, with the number and the x and the thing. So what's the highest power in my denominator? 8, right? X to the 8th. So I'm going to divide everything by x to the 8th. So 6 over x to the 8th minus 2x over x to the 8th plus 4x to the 3rd over x to the 8th minus 10x to the 4th over. This is overkill here. You get what I'm doing. I don't need this is just a lot. Divide by x to the 8th plus 2x squared over x to the 8th minus 1 over x to the 8th. Okay. Now, when I reduce this down, the first term's not going to change. The second term is just -2 over x to the 7th. The third term is 4 over x to the 5th, 10 over x to the 4th, minus 9, right? On the bottom, the x to the 8ths are going to cancel. 27 plus 2 over x to the 6th minus 1 over x to the 8th. But the moral of the story is there that if I make everything go to infinity, if I make all of the x's go to infinity, the reason why we divided by the biggest power, what's going to happen? 6 over a big number is going to eventually turn into what? 0, right? It's going to get smaller and smaller and smaller until it's negligible. So this is going to go to 0. 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 That's going to stay -9. This is going to go to 0. This is going to go to 0. So we have -9 27ths, which essentially is -1/3. It's funny. I was helping. What was her name again? Liz. I was helping Liz doing some exam review, and she had a problem like this, where it was divide by the biggest power in the denominator. But the problem that they had was they had a radical in the denominator. We actually did a couple of those in the homework and the notes, and it was like, okay, when I divide by like an x squared, remember what we had to do to put it back underneath the radical? You had to make it an x to the 4th. right? And so there was that weird thing where you had to like make it bigger. And then they went even so far as to put this as like a negative back there, like limit as x approaches negative infinity. So you had to calculate all those negatives in. And it was weird. It was weird.
Sounds terrible.
I know. Be happy that you have a high school teacher. There you go. Number 21. Given the following graph, state where the function would not be differentiable and explain why. And this is where I said you got to know the names of the discontinuities, because that's really what you're looking for, right? You're looking for any discontinuity and explain which discontinuity it is. Or there are other reasons when it's not differentiable. Because is there a discontinuity at 2? No. It is continuous at 2. But what is happening at 2? There's a corner point, right? There's a corner point. So where is this not differentiable? At 2. And why? Because there is a corner. Okay, where else is this not differentiable?
-1.
-1. And why?
It's removable.
It's a removable discontinuity. Discontinuity. Remember, the 3 types of discontinuities are removable discontinuity, jump discontinuity, and infinite discontinuity. This is a removable where we take the point out and we put it somewhere else, or we just take the point out and don't put it back in, right? Just an open circle, just a hole is a removable discontinuity. So what would a jump look like then? Well, if this is my graph, a jump discontinuity would be like, okay, we're here, we go down here, open circle like that, right? That is a jump discontinuity. What is an infinite discontinuity? Well, if that went up and then maybe like there, right? Where you have a vertical asymptote. That's an infinite discontinuity. Excuse me. Questions on that one? Moving right along. Now we're in chapter 3. And this is the stuff that's really familiar to us because we literally just took our chapter 3 test, right? So let's find the derivative. What do I have to use here? Quotient rule, yeah. F prime g minus g prime f over g squared. Right? F prime g minus g prime f over g squared. So let's do it. F prime g. Well, what's F prime? 3. G is 4x minus 1. G prime? 4 times 3x plus 2 over 4x minus 1 squared. Okay, we distributed into 3. So we got 12x minus 3 minus 12x minus 8 over 4x minus 1 squared. All right, 12x's cancel. Negative 11 over 4x minus 1 squared. I feel like this was on the review. Like, was that the exact same problem? We might see some.
It wasn't a 4x minus 1 on the bottom, but it was
Something really similar. I feel like
They
it was
might
an
have
11,
been
though,
low.
wasn't it?
It was
Was it
definitely
11?
11. I think it was the 3.
No, I did that review so many times.
Square.
I can't even remember.
Did that review so many times?
It was on the review. I can assure you. I can.
It was
assure you.
on the review. Oh no, that was derivatives review.
No, yeah, that's the exact same problem.
Is it really?
Yeah.
I wonder how many of these. Can I just look at that real quick?
A lot of them are the same.
A lot of them are the
Yeah.
same.
Yeah.
There we go.
And it's crazy. At least I
Like
have
these
stats.
stats.
Cotangent,
Facts.
cosine. Oh, these are the same. Look at those. I think I got lazy last year.
Copy paste.
Copy paste. Copy paste.
Maybe I'll learn it this time. Maybe it's not one.
Oh, it is the same. It is. This is the chapter 3 test review.
Copy paste the entire
Awesome.
thing.
You've already done that
There you
about
go.
Yeah, I've done that like 3 times and it just
Well, let's do this
didn't
then.
sink in.
Because maybe we don't need to go question for question with all of those. So let's pause here because we're kind of getting close to the end of class anyway. And then let's reserve, if you have any questions, I'll just open it up tomorrow. We can go over any of these that you want to go over from chapter 3. Probably, I'm guessing, like the related rates problems.
Yes.
We'll do those again. But other than that, I mean, it should be
Number 8. on
very
the test.
similar. Number 8 on the test.
Yeah.
We can go over test questions too if you'd like.
Yeah.
Yeah, so let's reserve that for tomorrow. Sound good?
Yeah.
Okay, let me stop the video and we can relax for a bit.
So chapter 3 is the majority of the